Welcome to Rival Institute. Now we are studying the gamma distribution. What is the gamma distribution? So in last class we studied the exponential distribution. In exponential distribution we have one bus stop. We can take some example. One person is waiting here. This person is waiting in the bus stop. So one bus is coming here. This bus will take this is a bus. Bus will take average 10 minutes. Average 10 minutes. So this bus is coming here. It will take average 10 minutes of time. This distribution, this waiting time distribution is explained in the exponential distribution. So is waiting here, one bus is coming, is average 10 minutes is taking. So this distribution we explained in the exponential distribution. Now situation is changed. Now one bus is taking, one bus is coming, and another bus is coming here. It is another bus. Second bus, this is a first bus. Second bus and a third bus. This is a third bus. Number of buses is coming. Here is a second bus and here is a third bus. Number of buses is coming. So here average time is taking for one bus. It will be a 10 minutes. So this is average time. It's not exact time. So this time between the events, that is a one bus is coming. Time between the events is explained in the 10 minutes of time. So time between the events, that we can call as a waiting time. That is a waiting time. Here is a time interval. You can write as a time interval. Here is the first time and second bus is coming. This is called the time interval. Or after one bus is passing, we are waiting time. We are waiting for the second bus. One bus is passed here and one bus is gone here. This is the first bus is reached here. Then it is a waiting time for the second bus. Then we are waiting for the second bus. One bus is passed here. So this waiting time is explained in the 10 minutes of time or 15 minutes of time. This is a waiting time. So each bus is passing is explained in the exponential distribution. So bus 1 is passed. Bus 1, B1. B1 is taken some waiting time. This average waiting time is 10 minutes. Another B2 bus. Again is a waiting time is there. Waiting time. Again this is a B2. This is a B3 bus. Again is a waiting time. So number of buses is passing in this bus stop. So this event is explained in the exponential distribution. This bus is for the exponential distribution. This bus is for the exponential distribution. This bus also is explained in the exponential distribution. And each buses, this event is independent. We can say independent. Here also this also independent. Each bus is independent. Here also independent. So each bus is not depending on this bus. This first bus is passed not depending on second bus. We can say only average time. What is the time is taking to pass this bus. So time interval between the buses, average time interval is explaining 10 minutes or 5 minutes or whatever. So each bus is independent. It may take 10 minutes or it may take 7 minutes. After passing first bus will take 15 minutes. So it is all are independent event. So the sum of this event, we are explaining about the 4 events, 4 buses or 3 buses. Here we are explaining 3 buses. This sum of this waiting time is explaining the gamma distribution of alpha and lambda. Gamma distribution of alpha and lambda. So alpha is explaining number of buses, number of events. We can say this is bus is here event. So one event, second event, third event. So alpha will explain alpha is equal to 3. We are analyzing for the 3 event. 3 buses is passing. If you 2 bus means we are analyzing 2 buses. So explaining about the 3. Lambda is the time interval. Average 10 minutes. That is the same as a time interval. If you are analyzing only one event, then exponential distribution. How to write exponential distribution of lambda we can write is approximately gamma distribution of 1 lambda. If you are analyzing only one event, it will be a gamma 1 lambda. Now we are analyzing 2-3 events, so it will explaining alpha and lambda. So here is a 3 event is there, so alpha become 3, like that. So this alpha is the alpha, we can call it is a shape parameter, and lambda is a scale parameter. And through the alpha and lambda, we have equation of probability density function. For Hs is lambda raised to alpha, gamma alpha, and S raised to alpha minus 1, E raised to minus lambda h. Gamma is equal to gamma 1 is equal to 1, and gamma n is equal to n minus 1. This already we have studied. So gamma distribution and all. This is a gamma alpha. It will call the gamma alpha. It's a lambda raised to alpha. So this is the gamma distribution. In gamma distribution, instead of one event, we are analyzing 2-3 events at a time. So this will explaining in the gamma distribution. So it's a alpha and a lambda. If you draw in the curve, we will get the positive skewness. So the gamma distribution will get the positive skewness, and shape is changing. So this is alpha is determining the shape, and lambda is determining the peakness. So here is lambda is equal to 1. It's a high peakness is increased. More peak. Here is lambda is equal to 2. More peak. Here is lambda is equal to 5. Less peak. So peakness is explained. Here also it's a alpha is equal to 5 only. Alpha may be some value 3. And alpha is equal to 2 some value. So in this lambda is explaining about the peakness. Alpha is explaining about the number of events. It is a shape parameter. It's a shift. This graph also will be a shift. So that is a alpha and lambda is a positive skewness, and gamma distribution is the continuous distribution. Gamma distribution is explaining in the continuous distribution. This one is a continuous. And this alpha parameter, alpha will be a positive. Alpha is always a positive. Why? Because each event is explaining in the alpha parameter. Here we can solve one problem, we'll understand. We are waiting in the bus stop. So average time is taking 5 minutes of time. In the bus stop, we are waiting for the bus. Average time is taking 5 minutes. And this average time is explaining in the exponential distribution. Average time is explaining in the exponential distribution. It is only 5 minutes of time. Each bus will come here. So we are analyzing only 2 buses. 2 buses. Here is waiting. He is waiting here. Is a waiting time is there. That is explained. He has to wait 5 minutes of time. So we have a 2 vehicle. He is waiting for the 2 vehicle. Here event is 2 event. We are analyzing for the 2 event. So each event has to happen in the 5 minutes of time. So we are analyzing 2 vehicle only. 2 vehicles. We are asking about the probability of Vx is greater than 8. Within 8 minutes of time, this 2 bus has to taking more than 8 minutes of time to reach the bus stop. So first bus may be reached within 3 minutes, 2 minutes, 4 minutes, whatever. It's independent. And second bus also reaching the another 5 minutes or time. So here asking this time is greater than 8 minutes. 2 bus has to pass here. 2 buses has to pass here. What is the probability of more than 8 minutes is taking for the 2 buses? In exponential distribution, we studied about only the 1 bus. Now here studying about the 2 buses. So what is the probability for the 2 buses passing? It will take more than 8 minutes. So how to find out more than 8 minutes? 2 buses has to pass. So here it is a probability we can draw 8 to infinity, more than 8 minutes. So here it is a lambda. Lambda is this one we can write is a gamma distribution of. Here we are analyzing two buses. So 2 and lambda is equal to exponential distribution average 5 minutes. So mean of the exponential distribution is equal to 1 divided by lambda. This is equal to 5. So lambda is equal to 1 divided by 5. So this is a 1 by 5. So this is a gamma distribution. We explained lambda raised to alpha. So 1 divided by 5 raised to alpha. 2 divided by alpha is gamma 2. And s raised to 2 minus 1 minus 1 by 5 h dx. We are going to integrate with the 8 to infinity. It is a gamma 2 and 1 by 5. How to integrate? Here it is a gamma 2. Gamma 2 is equal to 2 minus 1 factorial. So this value is equal to 1. And 1 by 5 square we can take out. This we can take out. It's a 1 by 25. And s 2 minus 1 it is a 1. So yes. So this we can say it is a u and v. We can integrate by parts. How to integrating by parts? So 1 by 25 I have taken outside and integrating by parts. Yes, h into e raised to minus 1 by 5 h divided by minus 1 by 5. So this is 8 to infinity. Minus of integration 8 to infinity. Differentiation of h is 1 and integration of by 5h divided by minus 1 by 5 into dx. So this minus 1 by 5 we can take it to top here, minus 1 by 5, so we can remove here. 8 to infinity we can pass here, and here also we can check this is outside. So plus is become 5 e raised to minus 1 by h. This if you are integrating again if you are integrating again here, if you are integrating 5 is here, integrating again minus 1 by 5, 8 to infinity. So dx we can change. So this will 1 minus 1 by 5, it is become again minus 25. This term is gone, and 8 to infinity. So if you give 8 to infinity, if you give inside, then you will get approximately 0.525 approximate value. So now we are analyzing, and the exponential distribution we are analyzing only one event is happening. So that is explaining the waiting time interval. Here 2 events is happening, 2 events or 3 events or 5 events, 5 buses is coming. So that will explaining in the gamma distribution. Hope you understood about this difference between exponential and gamma. So each event is explaining in exponential distribution like that. T1 is a waiting time T1 and T2 and T3 each event. So this is a waiting time. Here is waiting time. This all event is explaining exponential lambda. So sum of this event. So this sum of this event is explaining in the plus exponential, here also exponential lambda. So this sum of this event is explaining in the gamma distribution. Number of events is explaining in the gamma distribution for alpha and the lambda. Here how many events is happened? That is explaining in the alpha. That is the difference between alpha and lambda. Now we can find out what is the mean of the equation. What is the mean? Mean is explaining expectation of x. What is the expectation of x? We have to integrate here 0 to infinity x into lambda raised to alpha divided by gamma alpha s raised to alpha minus 1 e raised to minus lambda x. We need to multiply with the x. Now x, if you are multiplying here, x raised to alpha minus 1. So this x will go here, minus 1 will go. And we can take this is 0 to infinity. Alpha and lambda we can take out. Alpha and lambda I am taking out. Alpha and gamma alpha. So we got the x raised to alpha e raised to minus lambda x dx. How to integrate? This is a function u and v. Take a u and v. Previously we integrated the same way. We can integrate here. So first function, if you are taking lambda and alpha divided by gamma, alpha is taking out and taking big bracket. S raised to alpha is the first function into, first function is multiplied with e raised to minus lambda x divided by minus lambda. Divided by minus lambda. This is integration of second function v. So if you are integrating divided by lambda, and here is giving the bracket 0 to infinity, giving the 0 to infinity, and minus of integration of 0 to infinity, differentiation of first function, as you can alpha and s raised to alpha minus 1, differentiating here alpha and s raised to alpha minus 1, it's like x square, so 2x like that, differentiating here, and e raised to minus lambda x minus lambda dx. So integration of the second function. So this alpha and minus lambda is taking out, and minus symbol is taking out, here is plus symbol. So we got the, here is like that. Now you see gamma alpha and lambda raised to alpha is outside. So if you are giving the value 0 to infinity, 0, if you are giving this value 0, infinity given 0, so this both value 0, so this portion is gone. This portion we can clear it, it is gone. And here alpha and lambda is taking out, alpha and lambda, and here this value is there, is multiplying here, gamma raised to alpha divided by gamma alpha. So this term we can, if you are giving inside, alpha divided by gamma alpha, if you are giving inside, you see this is 0 to infinity, this is a PDF function, 0 to infinity. So this is a total probability will be 1. So expectation of x is equal to alpha divided by lambda. So this total probability is equal to 1. So we can write it is a 1. So it is become alpha and lambda. That is the expectation of x. So we got the expectation of x is equal to alpha divided by lambda. How to find out the variance of x? Variance of x. Variance of x, we have to find out variance of x is equal to expectation of x square minus expectation of x all square. This formula has to apply. So now we are applying for the expectation of x square. First we have to find out expectation of x square. So here we have a equation alpha raised to lambda gamma s square, we have to multiply h square. Here is a alpha minus 1. Alpha gamma lambda raised to alpha and gamma is taken out. We can write it as then only will not be any confusion. So integration of 0 to infinity h square into lambda raised to alpha divided by alpha, s raised to alpha minus 1 e raised to minus lambda s. So this is our formula. So h square, so here is a alpha, h square is there, h square into alpha. So we have to integrate again. So this portion we have to take out. This portion we can take out. So alpha raised to alpha divided by gamma alpha, we taken out. So here h square is there, h raised to alpha minus 1. So we can 2 if we are giving there, so this is become plus 1. So alpha plus 1, we got the alpha plus 1. Now we can integrate by parts. This is u, this is v. You can write dx. We can integrate by parts. How to integrate by parts is equal to we have a big bracket alpha divided by 1 alpha. So this is a s raised to alpha plus 1 and e raised to minus lambda x, integrating by parts. So first function multiply with the second function, integration of second function minus 1 lambda. So this is 0 to infinity minus integration of 0 to infinity, differentiation of first function. So this is alpha plus 1 s raised to alpha plus 1 s raised to alpha, and integration of second function divided by minus alpha ds. So this alpha plus 1 minus alpha we can take here. So this is alpha plus 1 divided by alpha. So this portion is taken out. Now you see, if you are giving to the 0 to infinity, here it is a 0 to infinity. If you give the 0, this becomes 0, and infinity this becomes 0. So this portion is gone. This is totally 0. This portion is gone. So this one we can multiply here. So you can write here lambda raised to alpha divided by gamma alpha. Now you see, gamma alpha I am taking to inside, gamma alpha divided by gamma alpha I am taking inside. Now you see 0 to infinity, gamma alpha divided by gamma alpha s raised to alpha e raised to minus lambda x. So this is the formula for the expectation of x. So this is equal to alpha divided by lambda. So we got the formula, expectation of s square is equal to alpha plus 1 divided by lambda into alpha divided by lambda. So this portion is equal to the, we already initially we are find out expectation of x. So this will get the answer of alpha divided by lambda. And now minus expectation of x, this is alpha divided by lambda whole square. So this will get alpha divided by lambda square. If we take a minus, then we will get like that, alpha divided by lambda square. So this is a variance of x. So we find out what is the expectation of x and variance of x. Expectation of x, we got the expectation of x is equal to alpha divided by lambda, and variance of x is equal to alpha divided by lambda square. So hope you understood about the gamma distribution. Gamma distribution, we are waiting time for the different event. Number of event is happening. That is explaining in the alpha value, and time interval between the event is explaining in the lambda. That time interval between the events will be in exponential distribution. And we are analyzing number of events. That is the gamma distribution. Hope you understood about the gamma distribution. Thank you.